Hello everyone, welcome to the Coders Hub YouTube channel. Today we are going to learn about JDK, JRE and JVM. Okay, the main concept of JDK, JRE and JVM in this session we will learn a deep description. Okay, the first thing is we need to learn a full form. What is JDK? JDK is the Java Development Kit, whereas JRE is Java Runtime Environment, and JVM is the Java Virtual Machine. In the right hand side of image, you just see that JDK contains tools for developing an application plus JRE, whereas JRE contains JVM and the class libraries. So, in this next slide onwards, we will go deep into JDK, JVM, and JRE. So, what is JDK? JDK is an essential tool for developing and compiling a Java application. Without JDK, you cannot able to compile a Java applications. So, JDK provides the necessary tools and libraries to write Java code. This includes the JDK includes compiler, interpreter, and all of the needed tools which is used for Java application. Okay, what is compiler and interpreter? So, for compiling our application, we need two things. One is compiler and interpreter. Whereas compiler in the sense it compiles the whole program at once and return us the errors what we have done in our code. Whereas interpreter in the sense it will read line by line and finds the mistake in each line and it will tell if a line gets error it will stuck there, and once we get corrected that line and it will to the next line itself. Okay, the JDK contains a compiler which is called as Java compiler, Java C, which converts our Java source code into a bytecode which is then executed by the JVM. Okay, so JDK, which is necessary for developing and compiling an application. So when we are developing an application, it will be in .java file extension. Once it is compiled, it will be converted into bytecode, which is .class file. So without JDK, we cannot able to compile our Java code in our system. So this is about JDK. Then what is JRE? JRE is the necessary environment for running our application. If in your application, uh, if you don't have JDK, it's okay. But the JRE is must, because once we get a compiled code from JDK, we can then able to run that compiled code, that is bytecode, in any of our system without JDK. But JRE is necessary because JRE contains the class libraries which we are used in our Java program for our applications. Like if we are giving the class libraries in the sense, it's nothing. It is something like if we are giving imports, we need some util packages, we just import the util packages, and all those libraries will be contained in a JRE. So for running JRE, for running Java application, we need JRE. Okay. The JRE is designed to allow user to run Java programs on their computer. If we have Java application already compiled, then JRE itself is enough to execute our code. JRE contains the standard libraries which we are using in our Java program. When we run a Java application, the JRE loads all the necessary class files which is initiated by JVM, and it provides the required libraries and resources to execute the application. If our application is compiled, then we need to run. Then JRE itself is enough. We don't need a JDK. Okay. Then this is the major crucial part where our whole execution takes place is JVM. JVM enables the computer to run the Java program, whereas JRE contains the class libraries and loads the class libraries which are initiated by JVM. See here is JRE loads all the necessary class files which is initiated by JVM. So from the statement onwards, what we are getting to know now, JVM is running our application. It takes help from JRE for the libraries we have used in our application. So JVM provides the main concept of platform independence in Java by executing the Java bytecode. It is executing the bytecode, not the source code. Okay. JVM always executes the bytecode. What are the functions of JVM in the sense? JVM first loads the bytecode. So if we the JVM, if we are giving any bytecode to the JVM, it first loads it to the memory. The bytecode which is a platform dependent code generated by a compiler. Compiler generates the source code which is platform dependent. Now it is a bytecode which is an intermediate one. Okay, then it verifies before executing the code, before executing anything, we need to verify whether it has any runtime issues. Compiler compiles any syntax errors or something, but the bytecode verification in the sense here it will checks whether it has any runtime issues or any violations has been taken, violated Java language, something it is not matching, it will throw a runtime error. Okay, then the JVM, once the bytecode verification is done, the JVM interprets or compiles the bytecode into machine code, whereas bytecode is not a machine code. First, JDK converts the source code into bytecode. Bytecode is the intermediate code where inside the JVM it converts the bytecode into machine readable code. Okay. In this, there are two main ways. One is interpretation and one is compilation. Already we know interpretation in the sense it will read line by line. So, reading line by line takes a lot of time. So, this method is slower. Because of this, we are going to compilation. Compilation in the sense just in time. At once, it will read all the lines of code, and it will generate any errors. That is what compilation. So we are using compiler, just in time compiler. To improve the performance of JVM, we are using JIT, whereas all the code is executed frequently and it speed up the execution. Then the execution part contains of this two only. Then memory management. This is the main area where in our Java application, the JVM manages the memories which are needed to be allotted and de-allotted. Okay, where here there are heap, stack, garbage collections, and so on. Heap in the sense, heap is something we can dynamically allot the memory for objects. Stack has methods, method calls, local variables, all the things are stored in a stack memory. Now, at this time, we just don't know what is objects, methods, method call, local variables, and all. But no worries. In upcoming videos, we will learn what is object, what are the methods, what are method calls, what is mean by local methods, local variables, and all. Okay. So at this time, you don't need to worry about it. Then method area. Method area is something where our class stores our methods, method data, and everything, constants, and all which is stored in a method area. And then program counter register, which is keeping track of current instructions executed by each thread. Then native method stack, which is manages the call to the stack. Already we have mentioned that there is a stack memory which where the method calls and local variables are stored. So the native method stack manages which stack or we are calling. So manages the call to the stack. Then garbage collection. Garbage collection is nothing. It is something like if we are not using some object for a long time and it has no life after that. So that time what the garbage collection will do now, it will automatically remove that object from the memory for freeing up the memory and to prevent the memory leaks. Then exception handling. Exception handling is nothing. If exception handling is something which is occurred during runtime, the errors occurring during runtime. While compilation, it is not showing any error. Then it's okay. We are don't having any syntactical error or something. But when it is thrown in JV, when it's thrown during the runtime, it is called as exception. Okay. So this is the internal structure of a JVM. If a class file is generated, it loads class loader, and after that our heap, stack, PC register, native, and everything, interpreter, JIT compiler, everything takes place inside the JVM architecture. So from this lecture onward, from this lecture, what we had learned in the sense, JDK is not necessary for running our Java code, whereas JDK is necessary for developing and compiling our application. If we have JRE itself, it is okay to run our compiled code, not a source code, compiled code. Because of this JVM, our language Java is the platform independent one. Okay, thank you. We'll see you in next lecture. Bye.